All right, so letter J, if we take a look at this point, so 1, 2, 3, disconnect that a minute. Okay, so 1, 2, 3, 4, 5. So it's 5 units out. And the argument there, the angle is 5 pi over 6. Or if we make it -5, so we've got to come over and see what this one is. So 11 pi over 6. Or again, just add pi. So 5 pi plus 6 pi gives us 11 pi over 6 to get that. All right, so letter K, we are 2 units out, and we are at pi radians. Or we could say -2 and 0, or 2 pi. All right, letter L, 1, 2, 3. So we're 3 units out, and we're at the 270 degrees, or 3 pi over 2. Or it could be -3 and pi halves if I subtract pi. So 3 pi over 2 minus 2 pi over 2 gives me 1 pi over 2. M, we're 4 units out, and we are at, so remember we're counting by 12, so this is 11 pi over 6, which would have been 22 pi over 12. And so this will be 23 pi over 12. So we're 4 units out at 23 pi over 12. Or if we make it in terms of negative, so if I subtract pi from that, that'd be 12 pi over 12. So we'll get 11 pi over 12. It'd be over here at the fork, so it would be right there. And then negative would send us over there. All right, so N, right here, we're 1, 2, 3, 4, 5, 6 units out, and we're at 7 pi 6 for our argument, or -6, and if I subtract pi, so 7 pi over 6 minus 6 pi over 6 gives us pi 6. So remember, the difference between these two would always be pi. When you make it the negative, just subtract pi to come up with the other value, or you can add pi. Either way would work, depending on where you are. And so you're always just sliding to the other side through the origin. All right, so if we need to convert rectangular coordinates into polar coordinates, so remember, rectangular coordinates are the ones you're used to, x and y, and the polar coordinates are when we have the modulus and the argument, so the r value and the theta value. So r squared always equals x squared plus y squared. Looking at our triangle here, so the hypotenuse is always equal to leg squared plus leg squared. And so then the cosine of theta is always going to be adjacent over hypotenuse, so it's going to be x over r. Or if we solve for x, we now see that x equals r times the cosine of theta. And the sine of theta is always opposite over hypotenuse, so we're going to have y over r. And so if we solve that for y, multiply both sides by r, we get r times the sine of theta. Tangent of theta equals y over x, because tangent is always opposite over adjacent. All right, so let's keep these things in mind and allow them to help us as we convert. So if we have 3, 3, and we need the polar coordinate, remember we're going to find r. So r will equal the square root of 3 squared plus 3 squared. So we get the square root of 9 plus 9, which would be 18, which we can break down as 9 times 2. And so we have 3 times the square root of 2. We could have recognized that it's an isosceles right triangle, 3, 3, so then 3 square root of 2, because it's always 1, 1, square root of 2. And then, so tangent of theta will equal 3 over 3, which is 1. So if the tangent equals 1 and we're in quadrant 1, it's pi fourths. So theta equals pi fourths. And so our polar coordinate is 3 square root of 2, comma, pi fourths. So if we have 2 square root of 3 and negative 2, so x is positive, y is negative, so we're down in quadrant 4. And so you could recognize this as 1, 2 square root of 3. It's just scaled up by 2, so we'd have 4 over here for our special right triangle. And so r equals 4. Again, you could do Pythagorean theorem if you needed to. It would be the square root of 2 square root of 3 squared plus negative 2 squared, but we're hoping that you are recognizing these special right triangles, so you don't need to do this. Oops. So we'd have 4 times 3 when we square it, plus 4. So we've got 12 plus 4, which gives us the square root of 16, which is the 4. Tangent of theta equals negative 2 over 2 square root of 3. So it's negative 1 over the square root of 3. So the reference angle there would be pi 6, 30 degrees, but we're down in quadrant 4. So 2 pi would be 12 pi over 6 minus pi over 6 gives us 11 pi over 6. So our polar coordinate 4, comma 11 pi over 6. All right, so negative 2, 3, that's over in quadrant 2, negative x, positive y. So now I do have to do Pythagorean theorem. This isn't one of my special right triangles or a Pythagorean triple. So r is going to equal the square root of 13. So the modulus is the square root of 13. So the tangent of theta equals negative 3 halves. So again, because this is not a special right triangle, I need the help of a calculator to figure that out. So on my calculator, I'm going to hit second tangent to do, let me clear out that div. Sorry, second tangent for the inverse tangent of negative 3 halves. And it gives me, let me make sure I'm in the right mode. I'm in degrees. Let me go to radians and try that again. Okay, so we get negative 0.98. Again, remember, inverse tangent is always between negative pi halves and positive pi halves. And so I need to figure out what is this actually. So we're going to take 2 pi minus that to figure out the correct radians. And so we get 5.3 radians. And so our coordinate, we've got square root of 13, comma, 5.3. Oh, actually, I put that in quadrant 4, but we need that in quadrant 2. Let's fix that up quick. We got to think about our quadrants. So we were supposed to be here in quadrant 2. This is a quadrant 4 angle, so I didn't mean to do 2 pi. We need to do just pi. Sorry, gotta always think about those quadrants. So pi plus this. There we go. Now we've got ourselves a quadrant 2 angle, not quadrant 4. So we get 2.16. All All right, and again, so my mistake there was I was putting it in quadrant 4, but this is a quadrant 2 angle. So I need the reference angle for quadrant 2, which means pi minus it, not 2 pi minus it. All right, so this next one's a quadrantal angle because we're at 0, -5. So we're just down here. So our modulus is just going to be 5 because we are just on the negative y-axis. So r equals 5. And then the angle there is 3 pi over 2. So this is going to be 5, 3 pi over 2. All right, so if we have rectangular coordinates, that's how we do it. First of all, we got to think about the quadrants. Don't make the mistake I did over here. You got to make sure you get yourself an angle that's in the correct quadrant. And then the modulus, so to find the r value, use Pythagorean theorem to solve for it. Use the inverse tangent to help you get that angle, but again, make sure it's in the right quadrant. And then it's always the modulus, the argument. So the r, the theta. All right, so now let's go the opposite direction. If we want to convert polar coordinates into rectangular coordinates. So recall that x equals r times the cosine of theta. We just did that on the other page. We knew that the cosine of theta would be x over r. So if we solve it for x, we multiply by r, we get this. We knew that the sine of theta would be y over r, and so we multiplied by r to solve for y. And so y equals r times the sine of theta. Remember that cosine always goes with x, sine always goes with y. All right, so if we want to convert to rectangular coordinates to find x, I'm going to take that r value, -2, times the cosine of the argument, 3 pi over 4. So I know that cosine in quadrant 2 is negative, and cosine of pi fourths is square root of 2 over 2. So the negatives are going to cancel out. 2 divided by 2 is going to cancel out, so I'm just going to get square root of 2 for my x value. And now to find my y value, I take the r value times the sine of my argument. Again, 3 pi over 4 is quadrant 2. So my cosine was negative, but my sine will be positive. And again, sine of pi fourths is square root of 2 over 2. And so the 2's will divide out here, multiply by 2, divide by 2, cancels, but we have the negative. So it'll be negative square root of 2 for y. So that coordinate pair in terms of x, y would be square root of 2, negative square root of 2. All right, new problem. So again, x is always the r value, the modulus, times the cosine of the argument. So the cosine of negative 240 degrees. Well, cosine of negative 240, so 360 minus 240, that's the same as saying 120 degrees. Sorry, I forgot my cosine. Can't forget my cosine. So it's the same as 6 times the cosine of 120 degrees, which is quadrant 2, so it's going to be negative. And the reference angle, so 120 is 60 degrees away from 180. So reference triangle or unit circle, whatever you prefer. Here's my angle for 60 degrees. So the cosine is adjacent over hypotenuse. And again, in quadrant 2, it's negative. So 6 times negative 1/2, we're going to get -3 for our x value. Y, we're going to take the r value times the sine of the argument. And again, negative 240 degrees is the same as 120 degrees. If I just take negative 240 plus 360, I get 120. So again, quadrant 2, sine is positive, and the reference angle is 60 degrees. So here's my angle. Sine is opposite over hypotenuse, so it's positive square root of 3 over 2. So 6 divided by 2 is 3, so we're going to have 3 times the square root of 3. right, a couple more examples here. So again, x is always the r value, the modulus, times the cosine of the argument, pi fourths. So we know cosine of pi fourths is square root of 2 over 2, and it's positive because it's in quadrant 1. So we get 3 times the square root of 2 over 2 for x. Y always equals the modulus times the sine of the argument. And again, quadrant 1, sine's positive, and the sine of pi fourths is square root of 2 over 2. So both x and y are 3 times the square root of 2 over 2. All right, one last example here. So again, x will always equal the r value, the modulus, times the cosine of the argument, the angle measure. Since it's negative 120, if we add 360 degrees to that, we'll get 240 degrees. So it's the same as the cosine of positive 240, which is 60 degrees beyond the 180. So here's our 60-degree reference angle. Cosine is adjacent over hypotenuse. And down there in quadrant 3, cosine is negative. So you're going to have negative 6 times negative 1/2. So you'll get positive 3. So y would be negative 6 times the sine of negative 120. But negative 120 degrees is the same as 240, positive 240 degrees, which again is a reference angle of 60 degrees. So the sine of 60 degrees is square root of 3 over 2. But down in quadrant 3, it's negative. So the negative times the negative is a positive. 6 divided by 3 is 3. And so we have 3 times the square root of 3. So our rectangular coordinates, x, comma, y, would be 3, comma, 3 times the square root of 3. And so that's how we convert from polar coordinates back to rectangular coordinates.